Hi, this is Maggie. In this video we're going to answer the question, how are binary numbers used to represent data in a computer? Well, actually, are binary numbers used to represent data in a computer? Not really. Data is represented in a computer at different levels of abstraction. At the hardware level, either on a hard drive or a flash drive or a DVD and RAM or on some other medium, data is represented using something physical. And whichever physical medium that is, it has two important properties. The first is that it has distinct sequential locations called bits. This picture from your text is an abstract representation of a hard drive with its magnetic bits. The other important property is that each of those bits can represent two states. You might think of them as on or off, or 1 or 0. So in hardware, you have a medium that has a contiguous sequence of bits of data that are all either in one of two states. And it's convenient to think of that as a binary number, because the binary number system has two digits. In this image from the text, bits magnetized one way are ones, and bits magnetized the other way are zeros, and they are contiguous, so we can interpret them as positions in the place value number system. So once we have that series of bits that are ones and zeros, how do we use them to represent something other than a binary number? How do we use them to represent letters, sounds, images, packets, videos, and all of the other content we access on computers every day? Standards are developed by institutions like IEEE, W3 Consortium, Unicode Consortium, and others to standardize the interpretation of how a series of bits encodes more complicated data. If we all agree that we are going to use 8 bits to represent a single character, and that 01000001 is the uppercase letter A, and we agree on different sets of bits for all of the other letters and many characters, then we can share text data, for example. That standard is an example of the ASCII standard for representing character data. Similarly, there are standards for larger character sets, the Unicode standard, floating point numbers, the IEEE 754 standard, packets of data that are sent over the Internet Protocol, and many more. Once we know a series of bits represents a particular kind of data, we can interpret it using the standard. One question that arises is how many bits are needed to represent a specific kind of data? A simple example might be the 26 letters in the English alphabet. If we were to represent only these letters, how many bits would we need? With 1 bit, we could represent 2 letters. One letter would be represented with a 0 in our bit, and the other would be represented with a 1. And then we've run out of patterns. If we have 2 bits, then we have 4 patterns, 00, 01, 10, and 11, and we can represent 4 letters. With 3 bits, we have 8 patterns, 000, 001, 010, 011, 100, 101, 110, and 111. We will need to use 5 bits, giving us 32 different patterns of bits to represent our 26 letters, because 4 bits, giving us 16 patterns, isn't enough. So we will have some bits left over. Maybe we could represent some punctuation marks as well with the extra bits, or reserve them for future use. One of the early standards for character data was ASCII, but with first 7 bits and then 8, very few characters could be represented, not nearly enough to represent all of the characters in all of the languages of the world. The Unicode standard was therefore developed. Another example of a standard being too small is the Internet Protocol standard. You can research some of the standards that have been developed to represent different kinds of data to learn about standards and the problems associated with representation in more detail.